Hello guys, welcome back to the next lecture of advanced DSA, and in this lecture we'll see linear search, or we'll begin with our searching algorithms, right? So linear search. But before that, if you are watching my video for the very first time, let me just give you a walkthrough. This is our website bigdatayatra.com, and in this you can book a free 101 call with us, or you can just explore our courses. This is the course Big Data and Apache Spark Mastery, which will help you acquire all the skills which you need to become a data engineer, and then Python with advanced data structures, of course. So these are the courses. You can look at the feedbacks given by students and in what all companies they are placed. And this is our Instagram, Big Data Yatra. You can follow us. We are posting daily reels here as well, and do subscribe our YouTube channel, guys. Now, without wasting much time, let me just come here in my notepad. Let's suppose you have this array, and in this array you have 5 elements, 1, and then you have 2, then you have 3, you have 4, you have 5. These are the 5 elements which you have. Okay, now I need to search 3. What I need to search? I need to search 3. What do I mean by search? I need to find where the element 3 is present, and where it is present, I mean at what index it is present. This is I want to know with the help of searching algorithm. At what index my element in an array is present. We always talk about at what index. People get confused that searching is about whether this element is present or not. If present, return true, else return false. No, this is not searching. We need to find the index where this element is present. If I will tell you that at what index element 3 is present, you will say 1 is present at index 0, because in array or list indexing starts from 0. 2 is present at index 1, 3 is present at index 2, 4 is present at index 3, 5 is present at index 4. So with the searching, I don't need to tell, yes, 3 is present in this array. No, I need to tell that 3 is present at index 2. I need to tell 3 is present at index 2. This is the main concept of searching, that tell me at what index an element is present in an array, right, or data structure. Correct? I hope this is clear why we need searching. And if now your question will be, what if the element is not present? What do we do then? Let's suppose I say find 25 in this array. I need to search 25 in this array. You will come here and you will see 25 is not present. So what index you should return? You should return index -1, saying that this 25 element is not present. This index -1, if we are returning, it means simply that we are returning none. It is not present. Don't think that -1 here indicates the last element. No, because in the array we have seen we can index like this as well, -1, -2, -3. So don't think if I am returning -1, I am talking about the last element. No, that's why I usually prefer to return none when the element is not present. But if we will look at the definition of linear search present in the online, then it says if element is not present, return -1, which I don't like personally, because it indicates that the element is present at the last index. But no, we need to return -1 saying element is not present, because in searching we always tell the forward indexing. We always tell the forward indexing, not the reverse indexing. You can return none as well, okay, as per the question and as per the interview. Okay, so this is the concept of searching. What searching says, I'm not talking about linear search currently. I'm saying if I want to search any element in the array, then at what index element is present, this I need to tell. If element is not present, return -1 index or return none. Okay, now we will see your linear search. Now we'll see linear search. Linear search, as the name suggests, say suppose I have this array A. I have elements like 10, I have 20, I have 30, I have 40, I have 50. These 5 elements I have, right? And at what index all these elements are present? 10 is present at index 0, 20 is present at index 1, 30 is present at index 2, 40 is present at index 3, 50 is present at index 4. Now what linear search says? The any element which you want to find, say suppose I want to find item 30. I want to find item 30 in array A. So what linear search says is step 1 is to start iterating through the entire array one by one. Correct. Step 1 is start the loop in the array, or start traversing array, or start loop, or start iterating. They all mean the same thing. Start the loop on the array and check one by one whether 30 is present at index 0, whether this is equal to 30 or not. That is, A of 0 is my 30 or not. Is it equal to 30? No. Then what do? We will proceed ahead and we will compare the next element. What is the next element, guys? Next element is 20. Whether array of 1 is equal to 30 or not? No, it is 20. So what we will do? We will proceed. Now we are here. Index 2. Whether array A of 2 is 30 or not? Yes, it is. So then what do we return? We return the index, that is 2. Return 2, saying 30 is present at index 2. This is my linear search. Search one by one, apply the loop in the array and compare every element with the item you need to find. If that element is equal to the element you are searching, then return its index. Right. Now, if I need to search 60, what will be the process? 60 is present, 60 is not present. But again, I will start the loop and I will compare array of 0, A of 0 with 60. Is it equal to 60? No, it is 10. So I will proceed. Now first index is equal to 60. No, it is 20. Then second index is equal to 60. No. 40. No. Array index third is 40. It is not 60. And then last index, it is 50. Then I have traversed my whole array. 60 is not present. Then what do? I return -1, saying element not found, or return none, saying 60 is not present. This is the linear search. Now let's talk about the time complexity. And we have already seen time complexity. We have big O, theta and omega. But whenever we write any program, and from the interview perspective, no one is going to ask us about the best case or average case, that is omega and theta. No one is going to ask. Everyone, they will ask you about the worst case, which is your big O. So whenever we will compute the time complexity, we will compute it on the worst case scale. Now help me find the time complexity, the worst case time complexity for linear search. Okay, to find the worst case time complexity of linear search, let's take one example. Suppose I want to find 10, right? I will start the loop and I will find 10 here as the very first index. So best case would be omega or big O of 1, right? This is the best case because 10 is the first element and 10 is what I am searching, so no need. But consider I am searching 50, which is my last element. Okay, so the item which I am searching is 50, which is the last element. I will start the loop. I will see whether it is equal to 50. No. Whether it is equal to 50. No. Whether it is equal to 50. No, no, no. Yes. Then whenever I will reach last, this is equal to 50. So how many operations I did, or how many items I searched, which will be equal to the number of elements present in the array. So the number of operations in linear search in the worst case will be equal to number of elements present in array. And why this is so? Because I will scan the entire array one by one, one by one, one by one. So the worst case complexity would be equivalent to big O of n, where n is number of elements in the array. I hope it is clear. Now, as we have understood the time complexity and about linear search and the searching, let's just go ahead in my PyCharm and let's write the program for the linear search. This is my PyCharm. Let me just write a program for linear search. What do? I will create a function called as linear search, right? And this linear search will take two arguments. What are the two arguments? The very first argument would be the array on which I want to search. This will be my first argument, which is array. And second argument would be the item to search. These are the two arguments, right? Let me just write here. First argument, array to on which we need to search. Then second argument, item to search, right? So let me just write it down, array and item. Okay, so this is my linear search arguments. Let me just cut it and paste it above. Now I will write program. What program I need to write? I will apply loop for the entire length, because I need to search the element one by one, and till what time I need to apply the loop? Till your last element. Say suppose if I have 10, 20, 30, and if I need to search 30, I will apply the loop equal to the length of the array. So what I will write, for I in range length of array. Say suppose this is my array 1 2 3 4 5, for example. Length of array will be 5. So in range I will have 5. It means my loop will run for 5 times. That is 0 1 2 3 4 5. Range of 5 means loop will run for I equal to 0 1 2 3 4, which are the indexes, because 1 is present at 0 index, 2 is present at 1 index. So loop will run for all the indexes, in short you can say. Now I will say if array at that index is equal to item which I am searching, right? Then what I need to do? I just simply need to return the index, which is nothing but the I, right? Which is nothing but I, correct? It's pretty simple. I will search in the array, and if that index is equal to 10, say suppose when I is 0 and I am searching 5, whether it is 5, array of 0 is 5, no. Array of 1 is 5, no. Array of 2 is 5, no. Array of 3 is 5, array is of 4 is 5, then I will simply return 4, right? And if not, say suppose the entire loop has passed, and if I am not able to find it, I will simply return -1, or you can just simply return none. I prefer none personally, because -1 would indicate the last element, which I told you. Okay, so this is the program, guys, for your linear search. This is the program, guys, for linear search, right? And here one thing to notice, else is not inside the for loop. I am writing for. Once the for loop finishes and my function did not return the index, then I am writing else, because I can use else with for loop too. This we have seen. If the loop has finished entirely and it has not terminated, or it has not stopped in between, then else will run, and obviously I want to return none. And this we have already covered for loop will else in our previous lecture. Do check out our courses. Then I can simply call it, right? Let me just define 11, 22, 33, 44, 55, right? Then I will just print linear search array of 11. I am searching, right? The first argument is array. This Second argument is the item which I am searching, right? So let me just run it. 0. Why? Because this 11 is present at 0th index. Let me just search for 55. 4. 55 is present at 4th index. It is working. Let me just search for 66. None, because it is not present. Now, your one question would be here, one important catch. What if I have duplicates in my array? What if I have duplicates in my array, right? Say suppose I have this 10, 10, 20, 30, 20. I have this 10, 10, 20, 30, 20. This is very important catch. So 10 is present at index 0, 10 is present at index 1, 20 is present at index 2, 30 is present at index 3, 20 is present at again index 4. So 20 is present at 2 index, you can see. Similarly 10 is present at 2 index. So which index to return? We always return the first occurrence index, first occurrence. Say suppose I searched here and the item to search here is 10. Then 10 is present at index 0, I will return 0. Simple. No extra checks will be done. Now 20 is present at index 2, I will return 2. No extra, the loop will stop and it will not check after it. Okay. So say suppose, let me just show you, the same code is working fine. So say suppose I have 22 here as well. Okay. So 22 is present at index 1, 22 is present at index 4 as well. Okay. Now it will simply return 1. Why? Because as soon as it will find 22, it will return. It will not scan the entire array. Correct? The loop will stop. So let me just run it. It says 1. So this is linear search. In case of duplicate element, we return the first occurrence of the index. Correct? Now what else we can do? And obviously we know the time complexity. The time complexity is big O of n, where n is number of elements. Correct? So I hope it is clear, and yeah, that's it. It's very simple linear search program. Do practice it on your own, and yeah, so we'll meet in the next class for the binary search.